All right, today we're going to learn how to find all the roots of our polynomials. We used to just be able to find our real roots, but now remember we've got those imaginary roots that we have been finding in our quadratics unit, and now we're going to have to do it again. Okay, so we're going to start off with this polynomial, and if we plug that into our graphing calculator, we're going to find one of the roots. Okay, and from our picture, we see that it crosses the x-axis at 2. Okay, so if we want, we can go ahead, sketch this out just a bit, and we know that here at x equals 2, that's one of our roots. Now we also have to remember the same number of degree is the number of roots that we have, which means the number of times when x equals 0, we can find 3 different numbers since our degree is 3. But it only crosses the x-axis one time. So that means that we have 2 imaginary roots that happen somewhere in between here. Okay? And today we're going to figure out how can we actually find those. Okay, so now that we know that we have a root at 2, okay, we're going to go off to the side and we're going to do our synthetic division and figure out what, if we divide our polynomial by x minus 2, what we have left. So maybe we can try to factor it again, because if we look at x cubed plus x squared minus 3x minus 6, we can't factor by grouping, we can't do our multiply add pairs, so we got to figure out how can I do this, and doing our synthetic division is something that we can do. Okay, and this is just because our traditional ways of factoring won't work. Okay, so that's what's going on here. We can't factor traditionally, so we're going to have to use synthetic division. All right, so we're going to drop down that first number and just do our synthetic division. Now, as you guys see, we've got a remainder of 0. Okay, that's good. When we have this remainder right here of 0, then we're in business, because we know that if a little factor divides a polynomial evenly with a remainder of 0, then it is a factor, which we already know that from our graph, because here it does cross at that x equals 2. Okay, so now we can go ahead and we can rewrite our polynomial. We can say x minus 2, and then we've got x squared plus 3x minus 3. Okay, and all of this still equals our f of x. Okay, now we can try to factor something else. Okay, we take a look at this, and this this little polynomial, okay, it's going to give us our imaginary roots. Okay, now I look at this and I can't do factor of grouping, and it's not a difference of squares, so I can't multiply to -3 and add to 3, so that means I'm going to have to use quadratic formula. All right, so off to the side, we're going to go ahead and write our quadratic formula. Okay, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. This is going to come into practice quite a lot during this section. Okay, we won't be able to do anything, and we're going to have to find our imaginary roots, which is when usually we use quadratic formula. Okay, so now using our quadratic formula, I'm going to say x equals my -3 plus or minus the square root of 3 squared minus 4 times a times c all over 2a. Okay, I'm going to simplify what is in the inside first. Okay, simplify what's on the inside first, and we've got x equals negative 3 plus or minus the square root of negative 3 over 2. Okay, when we have a square root of a negative number, remember that changes into an I. So right now we've got x equals negative 3 plus or minus I square root of 3 over 2. Okay, and we can break this down into x equals negative 3 plus I square root of 3 over 2 and x equals negative 3 minus I square root of 3 over 2. So here we have 1, 0. Here we have another. And then from the very beginning, that x minus 2, we've got our third and final 0 of x equals 2. So in this, I've got 3 zeros, and my degree is 3. So remember, if the degree is 3, I need to have 3 zeros. Okay. So what we need to take away from this is, when given a polynomial that we cannot factor, we're going to have to graph it, find a 0, and then use our synthetic division. Okay, so graph, find a 0, use synthetic division. Okay, we're going to do one more example on the next video. All right, our next example looks fairly similar, except instead of equaling to 0 or to f of x or y, right now it equals negative x plus 6. So our very first thing before we even get started is we need to make our polynomial equal to 0. So go ahead and move our negative x plus 6 to the opposite side. So now we have a plus x and a minus 6. Okay? Always make sure that things are equal to 0. Okay? Once we have this, we're now going to plug it into our graphing calculator. Okay? I've plugged it in already, and this is what my graph looks like. Okay? My graph, I can see on this one, it crosses in 2 different spots. Okay? It crosses at negative 3 and at positive 2. Okay? Now with this, I can pick either one of those and do my synthetic division. Okay? I'm going to pick 3 just because, but you guys can do whatever you want. So since it crosses at 3, I'm going to divide by that negative 3. Okay? So we're going to write out our coefficients. Okay? And then we're going to use our synthetic division. Okay, and we see that we do have that remainder of 0. Okay, so now I can go over here, I can write my answer in a little bit more of a factored form. Okay, and I remember I started with an x to the 4th, so in my synthetic I've got x cubed minus 2x squared plus x minus 2. Okay, now I can do a couple things. I can look at this and I can see, can I do factor by grouping? And it turns out, yes, you can. But just for practice sake, let's say that maybe we couldn't. And so we're going to look, and we've given another 0 here at x equals 2. So we're going to go ahead and we're going to take this polynomial that we have, and we're going to divide by 2. So off to the side again, we're going to divide by 2 because we found that there is a 0 at x equals 2. Okay, and I go ahead, I drop down my 1, and I am left with a remainder of 0. Okay, so now I know that this is going to be my next polynomial. Okay, so now I've got still my x plus 3. I now have an x minus 2. And here I've got x squared. This, I don't need to put plus 0x, so I'm just going to put plus 1. Okay. It dropped down to an exponent of 2 because I started with an x cubed. And remember, it's always 1 less for your highest exponent. Okay. Now, I know 2 of my zeros already. Okay, I know I have 1 here at x equals -3. I know I have 1 here at x equals 2. Again, I found those from the graph. Okay, I found those from my zeros right here on my graph. Okay, and now I've got to figure out what do I do with this guy. Okay, so I'm going to drop him down and I'm going to put him equal to 0. X plus 1 equals 0. So now I've got x squared equaling -1. Now, when I square root both sides, when you square root a negative number, remember it changes into I. So I've got plus or minus I. And you can't forget to also do your plus or minus or else you'll end up with 1 less root than what you need. Okay, so I've got another 0 at x equals I and x equals -I. Okay, so here on my graph, I've got 1, 2, 3, 4 zeros, and my degree is 4. So everything is accounted for. Okay, so just remember, when practicing this and when doing your homework, make sure that you have the same number of zeros as your exponent. Okay, it's going to be a little tricky. Okay, but if you find your zeros from your graph first, then it's going to be really easy to do your synthetic division. Okay, and remember, not always will you have to do synthetic division. Like on this one, we could have factored by grouping, and we could have gotten x minus 2 as one of our answers and x squared plus 1. Okay, so just make sure that you have all of your zeros. You will have to utilize the quadratic formula a couple times. I know for a fact on number 3 on your homework, you're going to have to use the quadratic formula, and a handful of others. Okay. Again, if you have questions, please make sure that you guys come in, ask me. Obviously, I'm not here today, but come in tomorrow, and we can get some things sorted out. All right. Good luck with your homework, and come in and ask questions if you have any. Okay. Thanks, guys.